What we're going to take a look at today is graphing quadratics when they are in standard form. If we remember, something that is in standard form is of the form ax squared plus bx plus c, where a, b, and c are all constants. Looking at this, the first thing anytime we're looking at graphing a quadratic, is we want to identify where the vertex is. And when we're looking at something in standard form, we have to use this formula to identify the x-coordinate of our vertex, and then we use that x-coordinate to figure out what the y-coordinate is going to be by plugging back into the function. So by looking at this, our b value is -8 and our a value is 2, so those are going to be the two values that we end up going through and plugging in just from looking at this, b being the coefficient for the x, a being the coefficient for the x squared term. So we would say negative b is -8, all that is over 2 times 2. The two negatives here should cancel one another out. We would have 8 over 4, and that ends up coming out to 2. So what that's telling me is the vertex, if we look at it, is going to have the x-coordinate 2. So we use that x value of 2, and we plug it into our original function to find out what the y value is going to be at that point. So this comes down to just evaluating this function. You just plug 2 in everywhere. When we actually go through and do this, you guys would have your calculator. You would end up having 8 minus 16 plus 5. What that's going to all end up coming out to is -3. So we would have the vertex be 2 to the right on the x-axis and down 3. And I can go through and label that. Now, the rest of this, we have to go through and we have to identify 2 points on the same side of the vertex. So we either want to find 2 points to the right, like x equals 3 and x equals 4, or plug in 2 points to the left, like x equals 1 and x equals 0. What we're going to go through and do, at least for this example, it doesn't really matter which way you go about doing it. We're going to do x equals 1 and x equals 0. So we're going to plug those values in, f of 1 and f of 0, into the original function up here. So we would plug in 2 times 1 squared minus 8 times 1 plus 5, and we would also plug in 2 times 0 squared minus 8 times 0 plus 5, and we go through and we just evaluate these using PEMDAS. To do that, we would have 2 minus 8 plus 5. What that all comes out to is -1. Alright, so that means f of -1, f of 1 is -1, so I would have the point 1, -1. When I plug in the x value 1, I got the y value -1, and I would go through and do the same thing over here to find out the y-coordinate when x equals 0. I would have 0 minus 0 plus 5, so what that's going to tell me is f of 0 equals 5, so I should have the point 0, 5. And I'm going to go ahead and plot these 2 points on my graph. The point 1, -1, and the point 0, 1, 2, 3, 4, 5. So what I have so far is this. And I can go ahead and I can label those as well, 1, -1, and 0, +5. So now from here I'm going to go through and I'm going to draw the parabola, the U shape of the quadratic. And just as a self-check, you should get something that looks like the U in the parabola shape. It shouldn't look like a line, it shouldn't look like a W or anything like that. And what we talk about here is these parabolas have symmetry. So what happens on the left of the vertex is going to happen on the right of the vertex. So I can go through and sketch the same exact thing on the other side. If you guys went about doing the points on the right hand side, you should have gotten 3, -1 and 4, 5, which we see are just mirror images across the axis of symmetry. Now, looking at this makes sense that our graph opens up because our a value is positive. It isn't negative. If it were negative, it would open downward. So the questions I was going to ask, what is the minimum or maximum value of this? What we can identify is the minimum value. We could see that the minimum value of the entire function is our vertex at 2, -3. So I could say the minimum is at 2, -3. Our maximum is just going to be infinity. These arrows tell us that it's going to continue to grow, 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 and grow. So there really is no point that we can identify as a maximum value, but we can identify the minimum.